7-3, square root functions and inequalities. I'm going to show you two examples today. The first one is objective number 1, graph and analyze a square root function. The second one is graphing square root inequalities. If you have your graphing calculator with you, you can definitely use it with these examples and follow along using your graphing calculator. So a square root function contains the square root of a variable. So here's the easiest version of a square root function. F of x equals the square root of x. One important note is that the square root function is the inverse of f of x equals x squared. That makes sense. The inverse of the power of 2 is the square root function. So these are inverses of each other. Let's check out what their graphs look like. So on the left here, I've got the graph of the function y equals x squared in blue. Then I've got the inverse in green. Think about it. If you flip each x and y point here and graph the mirror image, you get exactly this green graph. But there's a problem with saying y equals the plus or minus square root of x. We don't necessarily want the negative square roots in this case. Here's why. If you say that this green graph is the square root function, that's not exactly true because it doesn't pass the vertical line test, so it can't be a function. Let's think about that. If I draw a vertical line here, it fails the vertical line test. It's going to cross at more than one point. So this green graph here is not a function. Well, we want it to be a function because we want to be able to plug in an x value and get strictly only one y value. So to fix that, we want to think about the square root function as being only the positive square roots. So we're only looking at the top half of the graph, and this will be the general shape of all your square root functions. Okay, so keep that in mind. We want it to be a function, so we're restricting the values to say we're only using the positive square roots. All right, so here's the first graph. Y equals the square root of 3x plus 4. State the domain range and the x and y intersects. So to begin with, one thing to remember about these square root functions, or square root equations, I should say, is that we want only the real values. We want only real numbers. And we know that if we take the square root of a negative number, we're going to get imaginary solutions. Well, on our graph here, we only want real values. We don't want any imaginary numbers. So one thing to remember is that whatever's under the square root sign has to be greater than or equal to 0, because we don't want any imaginary numbers. We don't want to take the square root of negative values. So step number 1, you need to figure out what your domain is. Basically, what would give only real values or real solutions. So we set our square root equal to 0. This really represents the square root of 0. This is as low as we can go. We don't want anything below 0. So you say, okay, what is our minimum x value here? Well, let's solve it for x. Subtract 4 on each side, you get 3x equals negative 4. Divide each side by 3. And our minimum x value here is x equals negative 4/3. What I mean by that is that your domain starts at negative 4/3. That gives you the square root of 0. And we want everything to the right of that. So negative 4/3 to infinity is our domain. Think about why it has to be this way. We only want numbers greater than or equal to 0 under the square root sign, because I want to keep these values real. We don't want anything imaginary. So our domain starts at negative 4/3 and goes to positive infinity. Okay, step number 2, once you know your domain, you set up a table to get some points. Now, if you have a graphing calculator, this is where I would type in the function on my graphing calculator. You can find these points much quicker and easier using your graphing calculator. So the first point that I know is that negative 4/3 gives me the square root of 0, or 0. We know that if you plug in negative 4/3, you get negative 4 plus 4, the square root of 0, 0. Let's move on and plug in some other values. What if I plug in negative 1 for x? So the function becomes the square root of 3 times negative 1 plus 4. Well, that gives me negative 3 plus 4, 1, and the square root of 1 is 1. So negative 1, 1 is on the graph. Let's plug in 0. If I plug in 0, 3 times 0 is 0, plus 4 is 4. So I get the square root of 4, which is 2. 0, 2 is on the graph. Now I only want some whole numbers here, so I'm going to jump ahead and plug in 2. If I plug in 2, we get 3 times 2 plus 4. That's, oh, sorry. I shouldn't have done that. I said I only wanted whole numbers, so I'm going to skip 2. That gives you a decimal. I'm going to plug in 4 instead. Sorry, we're skipping 2, 1, 2, and 3, and we're going to plug in 4 instead. So 3 times 4 is 12. 12 plus 4 is 16. You might ask, why did I do that? Well, 16 is a perfect square, and I get a whole number 4. So if I were graphing this on my calculator, I would definitely only choose the whole numbers to graph. It's just much easier that way. So I've got 4 points here. I'd say that's about enough. So negative 4/3, 0 is the first one on the graph. It's important to find this minimum point here. So I've got negative 1 and 1/3 right about there. Negative 1, positive 1 is the next point on the graph. 0, 2. Then we skip some x values. If I plug in 4, I got 4. And you could see the general shape of the square root function here. It's going to come up. Whoops. And then it's going to cross here at 4, 4. Pen's not working well. And it's going to keep increasing to the right. So there's the shape of the square root function. I've already got my domain listed here. We're from negative 4/3 to infinity. When you think about domain, you want to think about the x values represented on your graph. When we think about range, we want to think about the y values represented on our graph. Well, the y values go from 0 to positive infinity. This graph will continue to climb. Even if it climbs pretty slowly, it's going to keep increasing. So the bottom y value on my graph is 0. And the y values go to positive infinity as well. The last 2 things to list here are the x and the y-intercepts. The x-intercept is where the graph crosses the x-axis, so that's right here at negative 4/3. The y-intercept is where the graph crosses the y-axis, and that's up here at positive 2. So when it says analyze the function, these are the 4 things you want to do. Domain, range, x-intercept, y-intercept. The second objective is graphing linear inequalities, or not inequalities, but not linear, but any inequalities. We have to think about, is our line solid or dashed? And then where do you want to shade? So solid or dashed, we need to look at the symbol. If you see a greater than or equal to, or less than or equal to, we want to make our line solid to say that the points on the line are included. If you see strictly greater than or strictly less than, that's when we make our line dashed to say these points on the line are not included. Finally, you're going to shade above or below according to your symbol. If you see greater than or equal to, you need to shade above. Anything above the line would be a solution. If you see less than or equal to, you want to shade below your graph. Okay, so let's keep that in mind when we do this last example. So we want to graph y is less than the square root of 2x minus 6. Now, according to the symbol here, the less than sign, I know 2 things. I know that my graph is going to be dashed and that I want to shade underneath the shape of the square root function here. Okay, so let's go through first and figure out where the minimum point is. Where does our graph touch 0? We're basically figuring out when the square root is 0. So you set 2x minus 6 equal to 0 and you solve it for x. We're going to add 6 on each side and then divide by 2, x equals 3. That tells you on your graph we've got the point 3, 0. If you plug in 3, you get the square root of 0, which is 0. So that's good to know. 3, 0 is our starting point, and the graph is going to increase from there. All right, so step 2, when you make your table now, and when you look at points to graph on your graphing calculator, you're going to start with 3, 0, and then plug in the next number, like 4, and then the next number, like 5. Okay, and I'll kind of stop there. So if I plug in 4, I'm going to take the square root of 2 times 4 and then subtract 6. So that's 8 minus 6. I get the square root of 2. Not exactly sure what that is, so I'm just going to put down 1 point something or other. Like 1.3 or something like that. I'm not really sure. Okay, if I plug in 5, I'm going to get the square root of 2 times 5 minus 6. So that's 10 minus 6, I get the square root of 4. This one makes me happy because it's a whole number. The square root of 4 is 2. So 5 2's on the graph. I'm going to go ahead and start my graph here. So I know that 3 0's on the graph. I know that 4 1 point something's on the graph, the square root of 2. So somewhere around here. And I know that 5 2's on the graph, right about there. So now I'm going to make my curve. This is not a straight line, it's a curve. And it looks something like that. Oh shoot, I forgot that I was going to make it dashed. Hold on here. Let me pick an eraser out. And then... Okay, so we want to make our line dashed. Hopefully you didn't copy me too quickly. So our line is dashed, and remember that because we've got a less than sign, I'm also wanting to shade underneath the line. So where does your shading go? Well, you need to make sure that you stay just underneath the graph. So we're kind of bounded here by this line x equals 3. And then anything else under the graph is a solution as well. Okay, so graphing inequalities, you just got to remember, is your line solid or dashed, and then don't forget to add the shading too. Okay, now everything I talked to you about today can be done on your graphing calculator. It's much, much quicker on your graphing calculator. So try to give that a shot with these two here. And if you need help with the graphing calculator, it can certainly help you tomorrow in class. So try these on your own, bring them with tomorrow.